Welcome to SERVOsoft, the optimal solution. This tutorial showcases SERVOsoft's powerful Servo Pump feature. The Servo Pump is part of the Pro version. The big advantage of a Servo Pump is efficiency, as it provides hydraulic power of pressure and flow on demand. When not needed, the system can be idle or provide just a minimal pressure and flow to maintain as needed. In SERVOsoft, the Servo Pump is just like any other axis, except that it is defined with a pressure and flow sequence, usually provided by hydraulics engineers. Let's begin. In this tutorial, we will learn how to define a pressure and flow sequence, select a servo pump from the database, import a complex dynamic pressure and flow sequence, size a 2-pump configuration, and size a variable displacement pump. Let's create a new servo pump axis with a simple pressure and flow sequence of 4 segments. So now we have the table and chart showing the pressure and flow sequence I have just created. Next, I will define the pump mechanism, which means specifying the oil kinematic viscosity and density, as well as the pressure offset between the tank and pump. Now I can select the pump from the database. I will select a Baumüller fixed displacement pump using a set of filters I prepared for this tutorial, with 25% flow and 15% pressure margins. I will choose the smallest pump that meets these filters. Also, looking at the chart, the IPv4-13 pump meets the pressure and flow requirements comfortably. I will click OK to accept the selection. And now I will quickly select a drive-in motor. And that's it! I've just sized a servo pump axis, including the pump, motor, and drive. Of course, we could insert a coupling between the motor and pump if we wanted to. However, I want to show a few features that highlight what the servo pump feature can do. I have sized just a servo pump axis based on a very simple sequence. However, the pressure and flow sequence can be as complex and dynamic as needed. So I will go back to the sequence. And now I will import a dynamic pressure and flow sequence from a text file or spreadsheet. Detailed pressure and flow sequences are usually provided by a hydraulics engineer. As you can see, this is quite a dynamic sequence. In the Select Profiles form, I can also chart any of these pump profiles. In addition to pressure and flow, I will also chart the pump total efficiency and leakage flow, the motor torque, and drive bus power. Now I will click the Y Scales 2 per plot button. You can clearly see the changes in total efficiency, leakage flow, motor torque, and drive bus power during the sequence. As you can see, the complex dynamic sequence is modeled in detail through the pump and then through the entire drivetrain to the drive. I can also use 2 pumps driven by 1 motor, where pump A, B, or both A and B can work to meet the pressure and flow sequence. In this case, I can choose 2 smaller pumps for more efficiency when only 1 pump may be needed for, say, half the sequence. So, in this case, I will make a copy of this axis and then configure it for 2 pumps and then define the sequence accordingly. The circuit diagram for 2 pumps is in the help file. Pump A and B are each enabled by a valve. When valve B is closed, then the B circuit is shorted back to the tank. So now that I have enabled 2 pumps, the next step is to modify the pressure and flow sequence for 2 pumps. So back to the sequence form. The first thing you will notice is the 2 extra columns for pump A and B, and only pump A is enabled. When I open a segment, you see there are checkboxes to enable or disable pumps A and B for each segment. However, I can also multi-select segments and enable or disable the pumps as needed. In this example, I will enable pump B to handle the higher pressure and flow demands of this sequence from roughly 6.5 seconds to 34 seconds. Now, with 2 pump sequence defined, I can select the 2 pumps from the database. The 2 pumps are selected as a pair. I will choose the 2 smallest pumps by displacement that meet the application requirements, which is the IPv3-6 and IPv3-5 combination. When either pump A or B is selected, the chart and performance data are updated to the right. Looking at the axis overall, the drive, motor, and pump are all good. Let's take a closer look at the drive and motor. The motor and drive look good. And then when I overlay the drive curves, it shows the motor is operating in the field weakening range. In this project, we sized fixed displacement pumps. However, we can also size a variable displacement pump. While this can be done with a 2-pump configuration, I will use axis 1 and size a single variable displacement pump. In this sequence form, click the variable displacement checkbox and then 2 new columns appear, start and end displacement. And the same inputs also appear in the segment form. First, I will change profile 3 to pump displacement to see how displacement changes over time. I will also disable profile 4. As you can see, the displacement is 0 for the entire sequence. Once again, I can import a pressure and flow sequence that also includes the start and end displacement columns. Or I can simply define displacement by segment, which is what I will do this time. I will set the first segment to the displacement of 5 centimeters cubed. And then I will copy that segment, select the other segments out to 1.5 seconds, and paste the displacement from the first segment. Then I will do the same for the segments from 34 seconds to the end. Finally, for those segments in between, I will define a displacement of 14 centimeters cubed. Now the variable displacement sequence is defined. So now I can go and select the variable displacement pump. Now I will open the pump database, and this time change the pump displacement type filter to variable. Only one pump meets the requirement, so I will choose that one and click OK. Once again, everything looks good for the drive, motor, and the variable displacement pump. In this tutorial, we learned how to define a pressure and flow sequence, select a servo pump from the database, import a complex dynamic pressure and flow sequence, size a 2-pump configuration, and size a variable displacement pump. This concludes the SERVOsoft tutorial on the servo pump. Thanks for watching.